Walid, you wrote, I know what is action detection. Excellent. Could you please explain the methodology for action recognition? What should you do and how to train model to detect action? How we can detect action from video in simple way? I mean, this is extremely difficult question for anybody. Thank you so much. Number one is action detection is very simple way. uh, we think that if there is an action, you just detect that, oh, suddenly somebody came, so I can detect the action. Okay, but in this slide, by the action detection, I meant temporal action detection, that if you have a video and there are multiple actions one after another, there is a break or pause, then you detect the starting point of the action and ending of the action. Then another action comes, so starting and ending of the action, something like that. So that is called action detection nowadays. The traditional action detection is very simple way, that I mean, by motion history image or optical flow. If there is some suddenly there no motion, suddenly motion came, so we can detect that there is an action, but not that action detection. So temporally action detection from untrimmed video or continuous video becomes the most difficult and challenging one. Number one. Number two, action recognition. You will find that, I mean, I told you that in 2012, 11, my first book on action recognition, and second book in 2013, both are available in Springer, and this year another book on action recognition, but on sensor based. Uh, in all those books, if you look, you will find that, I mean, the number of references are 500, 700, and most of the papers are only on action recognition because the title of the book is related to action recognition. So it means that there are several thousand papers on action recognitions and many methods on action recognition. Now, if you work on small data sets or a small domain, then action recognition can be done based on non-deep learning based, that means traditional handcrafted feature based methods. But recent all action recognition datasets, because they are very large, so many classes and lots of videos, so you need deep learning methods, and there are lots of different strategies. So what you can do, just go to the CV Foundation, I mean Computer Vision Foundation, or CVPR papers or ICCB papers. You just type action recognition, you find 10-20 papers. Look at those papers, you will find that they introduced different kinds of networks, deep learning based networks, and then they solve the problem. One of the earliest papers, they used two stream network from Andrew G. Sermon, if I'm not wrong, from Oxford University. So in that work, they considered like two stream means one is temporally, another stream you can consider that just the image spatial domain. And sometimes we use optical flow and use that optical flow, but remember, not the traditional optical flow like Lucas Canade method or Honshank method. Those are not used nowadays. So for deep learning based, there are 2-3 methods. In another presentation recently, I gave those information. I cannot recall exactly, so you can have a look, or if you want exactly more, then knock me by email or Facebook Messenger. I'll try to find and tell you. So that I can say. So there are many methods, so you have to check which one you like to look into. Samin Rahman says, seems very much focused on computer vision. In 5-10 minutes, can you share your life history, how you started down this path? uh, hmm, uh, oh my god, no. It is not possible now. Maybe another time we can discuss. Actually, there is nothing to say that much. I am extremely weak in terms of research, uh, but I am trying, so which I failed in my life. I don't want to see the same in the young generation, younger people like you guys, so that you can think bigger. So that's why I prepared this slide, because it took, I mean, lots of hours and efforts to prepare so many topics and ideas. And even though I wrote maybe few words, but I had to spend sometimes to know the word. like pre-recognition, p-recognition. That term I didn't know. So I looked into those, some of the papers, open, read. Most of the points I mentioned here, I had no idea. So but I learned, so that my younger people can learn. So I have no breakthrough. I am broken but no breakthrough. What type of researchers and native computer vision researchers should focus on produce good journals? uh, I mentioned many. So anything you do, if the work is like, if you consider action recognition or temporal action recognition, if you want to publish in a good journal or CVPR type conferences, you should give a result which is comparable or at least slightly better than existing good results. So this is the bottom line. Otherwise, reviewers reject the paper, number one. Another idea is that if you focus on new data set, smaller data set, nobody worked that much. Like I mentioned, many new data sets or smaller domain data sets or areas. If you work on that, only few papers, and whatever you do, huge chances to get the paper accepted. But when you submit a paper, remember to do as much as possible in-depth analysis, even though your result is not so good, but explain why. For example, at ACM UBComp this year, we had a competition, and my three teams from my students, they participated, and very lucky that one team becomes second, another one third. And what happened, that the data set is from nurse care data. Real nurse, they did some kind of activities in the hospital by almost 50 persons, and some different class imbalances, and extremely difficult. And the recognition result are, the top one got 22.5% roughly, and we got about 20 or 18% and so on. You see that as it is a new data set, real life data set, difficult one, very poor results. If you consider the 90%, 80% recognition results in other data set, but here we got very few, but still it is accepted, and so on. So you can check, I mean, and you have to focus on a domain and read and do at the same time for a longer period, relatively longer period. Don't think to publish quickly from one paper to another. If you have one paper, that's enough. But if you submit to a professor for PhD, he or she will understand that at least you can write a paper and you know the basic research methodology. But then if you have very good work, that will be very, very useful. The next question is that, walaikum salam. You mentioned that if work with medical image dataset, we should be careful to select those dataset. My question is, if I work with the already existed dataset that is available in some focus sites like Kaggle, is it okay? Of course, okay. Yes, yeah, you are working on breast cancer, wonderful. Kaggle, whatever dataset you get at Kaggle, you consider that more or less, I mean, these are okay. Okay, because unless it is useful, they don't put usually. This is based on my knowledge. So but I mentioned that be careful to select data sets if it is a very large data set, and if you do not have the capacity to run that large data set on your PC, then this is a problem. That's, I mean, my main focus for developing countries and Bangladesh and India and others, that we do not have most of the cases GPUs or multiple GPUs to run very large data set. So if we do not have that, so how can you judge your result? So you become fed up at some point. So that's why instead of looking into big data sets, you can try with similar problems but smaller data sets where there are, and try to see whether you can introduce a new method, and at the same time you try to learn something for the future. Publication is not only the thing. Okay, so video classification and action. Video classification means basically action recognition. Like object classification means object, like this is a cup, this is a camera, this is a table, this is a chair. The different classes, just simple pattern recognition concept for object. Action classification means, or video classification means, that one video is one class. Like I'm walking, I'm drinking coffee, I'm writing something. So mentioned three different classes. So if you have 300 different actions and you classify them, then those each video becomes one class or one pattern. So pattern class recognition, or pattern classification, or class recognition, or video recognition. By detection, I mentioned earlier, but I repeat it, that nowadays action detection domain, in a big domain, action detection means that temporal action detection, that continuous untrimmed video, that if one action is, let's say, that 3 minutes or 5 minutes, within this time, like for example, I'm cooking something, so I in the cooking I do 6 or 7 different basic actions. So can you separate one action and then another action? Just like speech recognition, it becomes very simple nowadays. I talk, I give pause, so you understand that I finish a sentence, then I start another one, I start another one. So you know that which one is the starting, which one is the ending. Through this process, you can recognize. Can we do the same for video recognition? You can try that. And I strongly recommend for researchers that video action temporally detection is difficult, but you try with difficult, but no problem, difficult is difficult, but we can challenge. But if you do not have, I mean, those data sets are huge, so that's the only difficult thing. On the other hand, you can consider skeleton based action detection or segmentation and so on. Sometimes these are overlapping because you detect, at the same time you must say that what kind of action it is. So not only detect, you may you say that starting and ending definitely, but at the same time you said that, oh, this first action was class A, next one was class X, and so on. Debashish wrote, how can we create new data set for further processing, as you are saying that they are not much on gate? Oh, gate has lots of data sets from China, from Japan, like our Osaka University, my lab, as well as in China and other places. But I mean that those data sets are huge, and most of the data sets, available data sets, are basically single person, and from the camera, and no object, and no occlusions, this kind of things. Now, if you want to make a new data set, then if you make just normal walking, then it's not, you don't need a new data set because there are already good data sets. So whoever wants to make a new data set, first check whether there are some good data sets or not. And your data set will be better than those data sets or not. That is the point. If you make a data set with new challenge, even if it is a smaller data set, but it is a good one. For example, face recognition is extremely well established method, you know that, but still there are challenges. For example, nowadays mask based face recognition. So consider that you make a good data sets, realistic data sets, and sometimes if there is less amount of data set, 4 or 5, you can introduce another one. But if there is already 100 data sets, then why do you need 101 data set almost similar? Sometimes we create, if you make good data set, that's fine. Some labs, like my previous lab in Japan, that lab say that every student must create their own data set, because by developing their data set, they can learn how to make the data set, and then through this process they can work, which is, I mean, one strategy by the professor, even though I didn't like, because he never opened the data sets to anybody. So in our lab, I mean, 5 years, you can say that we had 50 data sets, huge, if I consider that time, I mean, 15 years before. Anyway, you discouraged to work with medical images? No, 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 I didn't discourage. I due to less computation power. Okay, but if someone interested, then how or she overcome this? Okay, now I don't discourage. I just said reality check. Reality is that, I mean, we do not have enough computation facility for large data set. But if you find, I'm not working on MRI or CT, I had only two small works in the past. and on smaller data sets. But if you can find smaller data sets which is challenging, then of course you work on that, no problem. Now, how to overcome the computational power problem? Now, in Bangladesh, some of the labs they have, I mean, GPUs and other computation facilities. So one option is that you collaborate with them, discuss with them, and make collaborations with that professors or the teachers, and then but do the work so that, I mean, you can run and you can work over there. Remote access, I'm not sure whether someone has, but this is one option. During COVID, it will be more challenging. Google Colab gives very little. If you have money, uh, then it is important that you explore that money to buy some more resources at the Google Colab or similar kind of other things. These are the options. I heard that NVIDIA gave some GPUs free of cost for research and but I'm not sure whether it is applicable till now or not. But you can explore. These are the few things. I have no idea to say much because my students are suffering and I'm not able to help them much. Oh, another question. Privately, I have chosen my research topic on activity recognition, like violence, fight, hijack, etc. from public area. What do you think about this? This is excellent. I mean, there are few data sets on real life fighting, hijacking, kidnapping, killing, shooting, but you can explore those data sets. Abnormal, you search like this: abnormal activity data set, or abnormal activity recognition. So abnormal activity covers fall detection, fall down recognition, similarly violence, even fire, like someone, there is a fire somewhere, that sometimes car accidents, this kind of data sets are available as well. But make sure that before you start the work, you read top papers based on that data set or those data sets, so that you can get an idea that what are the approaches can be suitable based on that data set, because different data sets, they have different challenges and strategies, and do not consider to solve every point at the same time. Go one by one, and before starting something, know the domain. And initially you can consider that if there are 5 data sets, look at the simpler data set first. Try your method and see, so that you can run different way and find a good strategy, and then challenge the next data set, something like that. Most of the methods in action recognition or pattern recognition and others, except top methods, those are very well recognized. Most of the papers, they try only 2 or 3 data sets. If you look at the paper, even in CVPR, you will find that 2 or 3 data sets, or four is very rare. Okay. I mean, so most of the papers, because it is not possible to make a universal, I mean, it's possible, but it is very difficult to make a universal method that will solve, I mean, all the data sets and so on, because different data sets, they have different kind of, I mean, challenges or applications and so on. Asif wrote, can you place an RGB depth based and only depth based train dataset? How can I use them for depth estimation for monocular vision? Basically, I did not work on that, so I'm sorry that I do not have knowledge to answer your question. But depth estimation, hmm, I'm sorry, I don't have idea, so I shouldn't speak on this way. Maybe we can discuss in future, or you can tell more. The last question I can see that Hassana, can, can an action be predictable from video data? For example, if someone has a knife in his hand and there are several things in the room, can it be predictable that he's going to kill or cut fruit? Yeah, this is that's why, I mean, the action prediction or future action prediction. In one of my lectures in the past, I say that if I run with a rose, okay, with a flower, like Indian or Bangladeshi movie scenes, then you will understand that I'm running with a flower means something romantic. But if I run with a knife or gun or something else, then it is dangerous. So researchers' target is to predict based on the present situation. Can we predict the future? This is the this kind of work is going on, which is extremely difficult. On that case, you need to recognize the object, so human as well as object, and then you need to understand like this. So it's not so easy, definitely. It's a difficult one. Minhajur Rahman, behind computer vision pure research, there is good mathematics on the base. Of course, 100% exactly. These are very limited. I am a newbie. Okay. How to approach to develop good mathematical insights? This is a good question, and difficult for me because unfortunately I always say that I always feel bad that I am extremely poor in math, because during my time in my university, mathematics was, if I get 33% marks, if I just pass, then that's enough. So I was lazy on the time, even though my department I was the topper, but in the mathematics side I was the laddu guddu. I mean, extremely poor. I feel very bad on that now. Based on other good people's discussions, I find that linear algebra is very important. For computer vision, geometry is very important, because uh, I mean, different shapes, especially if you consider graphics related work, or shape related work, or material shape and so on, or geometry related work, you need geometry knowledge. Anyway, so another is that, I mean, you read deep learning related a basic book, go into details of this, understand the methods and mathematics behind this, and then through this process you can learn. It's a continuous process, and keep learning and reading. So that is the best option, I think. Yeah. Suppose my image classification model will run on video. Is it only video classification? Suppose my image classification model will run video. Is it only video classification? Okay. Um, this is a I let me say in a different way. You must understand that, I mean, I'm not an expert on most of the things I talk today. I just put the things. So when you say a classification, which I explained earlier for a question, that pattern recognition or classification, you need, like, if you have a video and the video is not action, but video has a bird, another video has a crow, for example, another video has a pigeon, another video has another action or something something something, say it like this, and you want to classify from the video, that the video is a parrot video, the video is a crow video, the video is a river video, or something like that, then it's a sort of an image classification problem. So in that case, you can basically say that you are classifying object recognition within the video. And basically we know that video is basically images. So if you have an image, and within the image if you have the parrot and you recognize that, then it's just like basic image classification. But if you have different opinion or different idea on this, then I can discuss. But normally action recognition or activity recognition or behavior recognition and analysis, we consider that one video has at least one instance of action or one kind of action. Another video has another action. Similarly, you have, say, 100 different kind of action classes by 200 people or 500 people or 1,000 people and so on. Then you try to classify. So that is, I mean, we say that human activity recognition based on video. Okay, have any quotes of Ahad Vision, sir? I'm very interested to learn from you. Anyway, so I have no quotes, uh, but we can discuss anyway. So I think that I didn't expect that much question, by the way. Thank you so much. But I expect that some of you, because we have some teachers and some young researchers here. So if you have any work that I mentioned you are working or you have some experience, you can share. Otherwise, it's already 90 minutes.
Sir, a participant raised his hand. Sriman Bidhan Baroi.
Sriman, okay, I cannot see.
Sir,
Hmm, okay.
I'm Sriman Bidhan Bari from University of Dhaka. The question I wanted to ask, you mentioned about generating artificial data where data is not available. Can you elaborate how we can generate artificial data
Oh,
like
thank you. Thank you.
working in
Very
an
good question. Uh, mm, uh, I don't have example here, but for example, let me move that slide to that point. I mentioned gait recognition, right? So, uh, gait recognition, I said that mm, just okay. Better I show the original slide so that just 1 second. Can you see another slide?
Yes, sir.
Okay, so um,
Uh, no, sir. It still says Gadda Gaveshana.
okay. So I just stop the sharing and reshare another one. Okay, so if you see this slide that I mentioned that occlusion. I mentioned that gait, I mean walking pattern, occlusion is a problem, but we do not have large scale gait data set with occlusion. So what we did in our lab, one of our PhD students, a brilliant guy, Dr. Joshim, he's from Begum Rokeya University in Bangladesh, and he published excellent papers on vision. So what he did, that 10,000 subjects he took. See, 10,000 subjects is not a joke, but in our lab we have 74,000 people for GATE dataset. So from that one large datasets we consider roughly 10,000 subjects, and then we create artificial occlusions in different ways, 8 different ways. So for example, this grayscale is basically black. Black means nothing is there. So consider that this is a bar. That means you cannot see the person's other leg. So we created a gate, GEI or silhouette, for example, and then partially we removed dynamic occlusions from left to right, and for example, static bottom or upside or sideways, left side or right side, and random locations. Through this process, we created many different data sets. So you can see that, I mean, here we just had normal, no occlusion, but we artificially created different kinds of situations, and through this process we created 24 patterns, like 30% occlusions, 40% occlusion, 50% of occlusions in the full area against I mean on against a silhouette. So this way we created. So this is one strategy. Another is that, I mean, you know that generative adversarial network appeared, and by this process we can do a lot. So this is another approach. And sometimes what we do, it depends on the data. Like actually last night, my two of my students, we had a meeting, Arafat and Nazmun Nahid. So they mentioned, but that is on another domain, that you add noise and increase data. You add some kind of patterns and increase data. You do interpolation on time series data, but on video, I mean, it's not so easy to make like that. So GAN can produce like that. Yeah. So these are the few things. Another is, I mean, for image, very traditional way is like cropping, but normally we do cropping like a smaller upload, rotation, and so on. So through this process, we make artificially created data. Yeah.
Thank you, sir. I missed in the middle because it disconnected, but I understand what it is. Thank you.
Yeah, but I basically I did not. This is from another slide, so I mean, so you didn't miss that part. Yeah. Thank you. Any other questions? I had few more slides. Okay. If no questions, oh, I think. Uh, okay. So another question is that could you please provide any study materials for hands-on action recognition? Okay, you knock me later. I'll try. You search first to see uh, good quality uh, survey papers. By the way, for to answer this question in different way, whenever you want to do some research, search for high quality survey papers related to that topic in the last few years. What do you mean by high quality? How can you determine? If you find a survey paper 10 pages, 5 pages, you consider 5 pages, 4 pages, 6 pages extremely poor. Usually high quality survey papers are 20, 30, 40 pages, say like this. Number one. Number two, of course, published in top journals or top conferences. So not small journals or small conferences. And you know what are the top journals and top conferences. Then the point is that uh, hmm, uh, I mean, who are the writers? So if at least one of the writers, normally survey papers are written by top, researchers. So if you, have one of the authors are IEEE fellow or big group, or they have previous good papers, so then you can trust on those cases. And then you just, read that paper. When you read that paper, you check whether it is sufficient for your answer. If not, then you try another paper, something like that. So through this process, basically you can find, so there are lots of good papers. If you do not search, if you search and do not find the full paper, then you after reading the abstract, if you feel that this paper is important, you can knock me. I'll try to download and share with you. Hands-on action recognition in the GitHub, there are many methods nowadays. But again, I find that all the methods or most of the GitHub codes are basically deep learning based on large data sets. But you must try, see, and check. No problem. What you can do, instead of running the entire full data set, you can make it smaller, like consider 10% of the data you are considering instead of the full data, just to learn how it works. This is another way. I mean, not for publication issue, just for learning purpose. You don't need to consider the 100%. Like for example, today I prepared puri. Puri is, if any foreigner, otherwise, I mean, it's a snacks. This is the first time. What I did, only 3 puri I prepared, and not so good quality, but it was okay. I tried. But if I tried with 1 kilo flour, and then I tried too much, and then everything is gone, which I tried during Jilapi time, during Ramadan, and all gone. So it was very, very difficult. So uh, point is that you try on a small domain of the dataset, a small portion of the dataset, and see how it works. There are lots of methods. Paper code, there is a website, paper code, you can search. In that website, regarding different computer vision related domains, they give 20, 30, 50 papers. Next to it, the full paper. Next to it, GitHub code link if it has, something like that, based on different data sets. So you just Google and get it. Okay. Oh, Samin already wrote it. Excellent. Paperswithcode.com. It is an excellent website. So have a look, and it has lots of ideas. But again, if you have no passion for anything, if you don't love video, okay, you can watch lots of YouTube or TV, but ignore that. If you want to work, one strong not a strong, one good recommendation I think, to work on skeleton data, because skeleton data is basically for one image or one time series, one time you get 25 body joint points. If each point is only three values, x, y, and z. Now you see, so small amount of data compared to an image, so many pixels and so on. So skeleton data are easier, smaller in size, and you can explore in many ways. And skeleton data based different medical and hospital related applications will be more useful to explore, I think. And one point is very important, that if there is a vacuum in a domain and you try something, whatever result it gets, this is a good thing. So that is my, I mean, suggestion or view. And basically a good number of my students are working on that. To make a data set as a skeleton is a problem. That's a good point. You cannot make a data set unless you have uh, Kinect sensors or Azure or related sensors. But already there are 80 plus data sets on a skeleton. For example, I can give you an idea. Think about 20 smaller datasets on a skeleton. Why don't you consider that, okay, from 20 different skeleton datasets, I will make one dataset and make it difficult? How can you do that? 20 datasets, each dataset has some common actions. You collect all the skeletons per person, all the classes, I mean, for one class, all the person's data, another class, all the person's data, another class, maybe not all, maybe 10 different data sets, and get the data. So what you get, you may create a new data set based on existing 20 dataset, and the dataset can have 20 different action classes by maybe 70 people for one class, another class maybe 100 people. And as the datasets are taken in different environment by different people, different diversity, so your created new dataset will be very difficult, challenging. You did not create the dataset, you just compiled the dataset, make it a complex one, and then you try. This is one strategy. And I found few papers, they tried with 4 or 5 different data sets, and what they did, they even didn't propose a new method. They ran on existing 5 other methods and compared that, and they say that those 5 methods, actually this idea, my few I mean 2 groups are working on that, okay, but still you can do, no problem, okay. As and some of you, if you are extremely, I mean, interested, we can discuss later to give more ideas so that you can work on that, okay. So the point is that this way you can do. Another, I mentioned temporally segmentation. Video, you have a video, different actions you want to segment, or temporally you want to separate or detect, and so on. In skeleton, you may not have that data, but see whether there is any data set where they have something like that. I know 1 or 2 data sets, they have multiple 3 or 4 actions in one sequence. So that data set can be considered for this purpose. Or you can join 2 or 3 data sets, I mean 2 or 3 classes, and make one sequence, and then another 2 or for the from the same person, and another 2 or 3 classes from the same person, make another one, something like this. So then you have a data set and then use for that. uh, and definitely I have a Kinect sensor, but one of my students took it uh, from another colleague to whom I gave, and that student didn't return it. So unfortunately, I mean, I cannot recall who the student is, and my Kinect sensor is gone. Another eye tracker is gone. I mean, the student should return on time, but they didn't. So if those things are shared by another student, another group, then somebody else can work on that. So this is another, I mean, sad that we don't have this, but definitely some of us in Bangladesh have. If anyone has a Kinect version 2 or Azure or something, share with me, or you can buy and explore research areas. And I'm sure that there are, I mean, data sets you can make or you can get. Any if you Google, you can get the cost. Kinect version 2 is not available now. They stopped, Microsoft stopped it. They brought another new one. So maybe you can Google. I didn't check the price. Sorry, few $100 most likely. When I bought it from US, I mean, roughly 10 years. I mean, when Kinect version 1, when 2011 or something, I forgot. On that time, it was 150 or something dollars, I guess. I forgot. But now, I mean, it's not so expensive. Yeah. Any other question? If not, we already passed 2 hours and participants half left. So with that, I would like to thank you all for joining uh, this session, and we hope that you will attend the uh, mm, next one. Next one will be from Professor Sozo Inoue. Very interesting work, and sensor-based, smartphone-based human activity recognition, and they created a good amount of realistic nursing big data, and you will find lots of ideas from his presentation, and we can do this kind of things in Bangladesh or other countries developing areas. So I hope that mm, that would be uh, good to listen from him. And with that, I thank you everyone for your time and patience to listen 2+ hours, because I
Thank you,
started
sir.
exactly the same time. And we hope to discuss more. My main target to initiate this talk, because I found that lots of young researchers, they want to do, and video processing or image processing very easy to get data, to create data, so we can do a lot. And please do a lot. I hope that today's discussion will ignite more research areas and topics, and anyone interested to discuss further, knock me in Messenger. I remain busy, but I'll try to give time. We can discuss at least once or twice on few things, and then you keep on trying and do the best. With that, I would like to thank you all, and hope to see you again in the future. Thank you so much. All the best. Stay safe, and don't take COVID-19 as a lazy thing, or I mean, don't be Donald Trump, okay? That's the point. Be serious, because if Donald Trump can get COVID-19 and others, it is a serious thing, of course. So please remain safe, okay? Don't take it lightly. Thank you so much.